Good day, MTChem. Let's now proceed with the part 2 of the module 3 for MTChem lecture, which is chemical calculations. Let's have a look at our module outline again. So we've already finished discussing chemical equations, writing and balancing chemical equations, and the different types of chemical reaction. So now we'll proceed with the discussion about chemical calculations, which has a lot of subtopics, which is measurements in chemistry, significant numbers, rounding of numbers, scientific notation, formula mass, moles, specifically about molar mass and Avogadro's number. If you've noticed, chemical calculations is divided into 3 more parts. That is so that you can have breaks in between, so that you won't be bombarded with a lot of information regarding these calculations. During our discussion, kindly prepare your periodic table and your scientific calculator. For chemical calculations, at the end of this lecture, here are our objectives. So you should be able to first define a mole and use Avogadro's number in calculations, and solve different chemical calculations such as formula weight and molar mass. The topics before formula mass and mole, like measurement, significant numbers, etc., these are building knowledge so that we can have a much easier discussion for formula mass and mole. Let's start with measurement. So when we say measurement, this is the determination of dimensions, capacity, quantity, or an extent of a something. So here are the common measurements that we use. In the world, the most commonly used metric systems are English and the metric system, okay, or the measurement system. In the West, usually they use this English system, but in the Philippines and used in chemistry are the metric system. So let's define what are the common measurements to use in chemistry. So in measurement, we usually talk about mass. What is mass? Mass is the measure of total quantity of matter in an object. How much quantity does it hold? Okay, how much matter does it hold? So our unit of measurement that we use here would be grams, with the symbol unit which is small letter g. This is the basic unit of mass in metric system. Next will be the volume. This measures the amount of space occupied by the sample. How much space do you occupy? Do you expand? Okay. And the unit of measurement used for that is liter, which is capital letter L. This is the base unit of volume in metric system. Next is length. Okay. Of course, this measures the distance between 2 points. It's like how far it is from where you're standing to another point of the door. It's like that. Basic unit of measurement here, or base unit of measurement, is meter, which is symbolized by small letter m. Okay, because the capital letter M symbolizes other. So these are the usual measurements that are used in chemistry. Here are the prefixes that are commonly being used, and their symbol and their multiplier when converting measurements. We have exa, which is capital E, beta, which is capital P, tera, capital T, giga, capital G, and then as you can see here, mega is capital M. So don't confuse it with meter, okay, which is small letter m. And then you also have milli, which is small letter m. Okay? Okay, let's now proceed with the conversion of units. Okay? So let's try to convert this one first. So convert 2 meters to millimeters. So we all know that 1 meter is equals to 1000 millimeters. Okay, so how do you convert it without the use of calculators? So you first write 2 meters, okay, multiply it by 1000 millimeters since that's what you're converting over 1 meter. It's equivalent. And then you cancel out you cancel out meters and then you simply proceed with the multiplication. So you have 2 times 1000 is 2000 millimeters. Don't forget the unit of measurement. And then since this one is simply 1, you don't need to put it. And then this will be your final answer. You have 2000 millimeters. With this, you might be thinking, oh, do I have to memorize all of the conversion table? You don't actually. So let me show you a way, okay, on how to shortcut the conversion method with the use of KHD underscore DCM. Okay, with the use of this acronym, okay, you can immediately convert a base unit, okay, to different to different quantities of measurement. So K is for kilo, H is for hecto, D is for deca. This one, the underline this is the base unit. When we say the base unit, it's either meter, grams, or liter. Okay, you have the base unit here. Then next, we have the deci, centi, okay, centi, and then milli. Let's try to convert it using this acronym. So again, we have the KHD, base unit, DCM. Since we're looking for, the base unit for this one is meter, so let's put it here. Okay, and then we're converting it to millimeters, which is this one. So what you're going to do is you count how many times you have to move before you reach M, this milli. So you have to say 1, 2, 3. Okay, so your movement was 3 times. And then also take note of the direction. That's 3 times to the right. Okay, now you use this now to convert 2 meters to millimeters. How do you do that? Remember, you have your quantity, which is 2. Okay, and 2 has a decimal point in this one. Okay, but we don't usually put it since there's no number following that decimal point. But there is a decimal point beside 2. So all you need to do is move it 3 times to the left. So you have to move it 1, 2, 3. Okay, and then your decimal point will put here. So what do you do with these spaces? You just fill them with zeros. Okay, and then this will be your final answer, which that will be 2000 millimeters. Okay, again, you simply take note of how many times does it take for you to reach your destination or your target unit of measurement. Take note also of the direction and then use that to get or to convert the given unit of measurement. Okay, as you can see, we arrived at the same answer. Okay, let's check another one. Let's try to convert another one. This time we're converting mass. So we have here milligrams to kilograms. Let's try to use the KHD and the DCM method. Okay, so for this one, let's write G as our base unit because we're looking for kilograms. Okay, now since we have here 500 milligrams, the decimal point should be here. Okay, but how many times do we need to move and to where? You're located here. Okay, and then your point of destination is 2 kilograms. So let's start. That will be 1, 2, 3, 4, 5, 6. Okay, that's 6 times to the left, meaning you have to move your decimal point 6 times to the left. Let's count. 1, 2, 3, 4, 5, 6. And then your decimal point will be here. Fill out the spaces with zeros, and then your final answer should be 0.0005 kilograms. Okay, you get the kilograms because you're converting it to kilograms. And then this is now your final answer. Here are the usual units of measurement that we will be using for our chemistry subject. So we have here the physical quantities, name of unit, and their abbreviation. For mass, we usually use kilogram with the abbreviation kg. We also sometimes use grams and milligrams. For the length, we use meter with the abbreviation small letter m. For time, we use seconds, abbreviation sec. For temperature, we use Kelvin with the capital letter K. Sometimes we also use Celsius with the abbreviation degrees Celsius. Let me write it. Sometimes we also use Celsius or degrees Celsius. And then for kilogram, we also use grams and sometimes milligram. For the amount of substance, we use mole or mol, sometimes just M. And then for the electric current, we use ampere with the capital E. And then the luminous intensity or how bright something is, we use candela or CD. Okay. Hopefully, the shortcut method that we discussed is a lot more easier for you to use. Hopefully, you won't have difficulties in converting these types of units.